video 6 on sketching quadratics, and in this video we're going to talk about some examples of sketching quadratics using transformational form. So I'm going to run through these two examples that are given. One's already set out for us quite nicely and it's fairly simple, and the other we're going to have to do a bit of algebraic work on. But let's run through this very quickly. So the first one is y equals 3x plus 6 squared minus 3. So you'll know that this 6 represents our negative h. And so therefore h is equal to negative 6. And you'll also know that this 3 represents our k, but the negative goes with it. So k is equal to negative 3. And of course, we have a is equal to 3. Now the h and the k are really simple. I'm going to show you how to deal with the a equals 3 though, in such a way that you can draw these quite quickly. But there are lots of ways you could do this. The h and the k represent our turning point. So our turning point is h comma k, which in this case is negative 6 comma negative 3. So I'm actually going to plot that on now. Negative 6 comma negative 3 is right here on my function. And that is my turning point. A is positive, so I know that this function goes upwards. It's a smiley face quadratic. But a is 3. Now here's the interesting thing about a. If a is 1, a standard quadratic, well, standard quadratic, because 1 squared is 1, has the special property that as you go along 1, you go up 1 in the first instance. As you go along in 2, you go up 4. It's a quadratic, so you move along 2, you go up 2 squared. As you go along 3, you go up 9. The effect A has is that it just multiplies this overall effect. So now, instead of going along 1 and up 1, we now go along 1 and up 3. And you can see the steepness this has. If I go along 2, instead of going up 4, I now go up 12, which is actually off my graph. So now my graph is going to look like this. And there we have it, our parabola. We could do some tests on that, of course. We could show that the two x-intercepts here are negative 5 and negative 7. But we don't need to do that. We're pretty confident with our transformations. And you'll also note here that this is taking the standard parabola, which looks like this. It's shifting it down 3 spots. It's shifting it left 6 spots. And then it's making it steeper. So here is our down 3 spots, left 6 spots, and making it steeper. That's what transformations are all about the idea that if we understand the transformational form of a function, then all we have to do is make some translations and some dilations, and we're done. So if you understand that transformations, then you're pretty good with that. Scooting down now, we have a function that is not in transformational form. So our best bet here is to put it into transformational form, which of course is completing a square. So here's a bit more practice for you. And I'm going to do this my way again. So if we complete the square here, I'd start by factorizing the quadratic and linear term so that I get a nice unitary linear term. So I get 2x squared plus 4x plus 7. I'm not really that fussed about the 7 yet, so I'm going to leave the 7 on the outside. Now I do that, take the linear term, which is 4x, take the 4, halve it, and square it and add it on. That's going to give me a perfect square. So x squared plus 4x. And then when I halve it and square it, I get 2 squared, which is plus 4. And x squared plus 4x plus 4 is a perfect square. But I also have to do the minus 4 component. And that way, I'm not actually changing the function. So I've added 4 and I've subtracted 4, which you should agree is just 0. And now I can write this down as 2x plus 2 squared, and I've still got that minus 4 left over, plus 7. And now I can finish this question off, giving me 2x plus 2 squared, and then that 2 times minus 4 gives me negative 8 plus 7, which is 2x plus 2 squared minus 1. And of course we have k equals negative 1, h equals negative 2, and a is equal to 2. And so we have a turning point at negative 2, negative 1, which is here. And this dilation here of 2 means that if we go along 1, we go up 2, which takes us to there. If we go along 2, we go up 8, which actually takes us to there just on the graph, and I can mark it symmetrical, so it's the same on both sides, and this is what my function looks like. So there you have it. Using transformational form to sketch quadratics is quite easy actually, and if you have a deep understanding of the fact that transformations aren't just about finding the turning point, but they're about the shifts or the translations that happen from the center and then the dilations that are applied, this is quite easy and quite an easy process for a lot of different functions, which will really help you in year 11 and 12. All the best.